Water is often perceived to be ordinary, as it is transparent, odorless, tasteless, and abundant in many places. It is the simplest compound of the two most common reactive elements, consisting of just two hydrogen atoms attached to a single oxygen atom. Very few molecules are smaller or lighter. Liquid water, however, is a most extraordinary substance. Water is essential for life. Earth's inhabitants cannot live without it. It is equally important to the environment and the water cycle that drives the intricate balance. Over 70% of the Earth is covered with water, 326 million trillion gallons. The oceans hold most of the Earth's water, but water is also present in the polar ice caps and glaciers, aquifers and wells, and lakes and rivers. Only 3% of the world's water supply is freshwater, and 77% of that is frozen. The Earth's water is always in motion and commonly changes states between solid, liquid, and gas. Some water floats in the air as clouds and water vapor. The natural water cycle, also called the hydrologic cycle, is the continuous movement of water on, above, and below the Earth's surface. This cycle is powered by solar energy. The water cycle involves water evaporating or turning into a gas, rising up into the atmosphere, cooling and condensing into drops of water or ice crystals that we see as clouds, and falling back to Earth as rain, snow, or hail, before evaporating again and continuing the cycle. Water moves from one reservoir to another by the physical processes of evaporation, condensation, precipitation, infiltration, runoff, and subsurface flow. The water cycle involves the exchange of energy, which leads to temperature changes. Water is a molecule with one oxygen atom and two hydrogen atoms, bonded together by shared electrons. It is a V-shaped polar molecule, meaning it is positively charged near the hydrogen atoms and negatively charged near the oxygen atom. This polarity makes water molecules naturally attracted to each other, where they form hydrogen bonds. This bond is behind what makes water properties so unique. Cohesion is a property that allows water molecules to stick to each other. Adhesion properties mean that water molecules also stick to other materials. Because its adhesive properties are stronger than the cohesive forces, the water spreads out as opposed to sticking together in a mass. In its solid form, ice, these hydrogen bonds are what give it the ability to float on its liquid form. Water molecules form a crystalline structure at freezing temperature, which is less dense than its liquid form. Hydrogen bonds also affect the thermal properties of water. This is important in terms of climate because water has a high specific heat index or heat of vaporization threshold, meaning it can take large amounts of heat before its temperature rises considerably. Air pressure affects the boiling point of water. Water boils at 100 degrees Celsius or 212 degrees Fahrenheit, but this is at sea level under normal conditions. The boiling point of water changes relative to the barometric pressure. There are often several minerals dissolved in water. The presence of these minerals is the difference between hard water and soft water. Hard water usually contains calcium and magnesium, but may also contain other metals. It can cause limescale deposits in pipes, water heaters, and toilets. Water is a universal solvent, meaning many substances, such as salt or sugar, dissolve in it. Substances that dissolve in water are hydrophilic. This means that they are as strong or stronger than water's cohesive forces. Substances that naturally repel water, causing droplets to form, are called hydrophobic. Salt and sugar are examples of hydrophilic substances. They dissolve very well in water. Both hydrophilic and hydrophobic materials can have effects that are beneficial in a variety of functions. Substances like these can have significant impacts on how things are manufactured, such as power plants, desalination plants, electronics, materials for transportation, as well as airplanes and even food packaging. Plants are often over 90% water by weight. They contain a higher percentage of water than animals. Just as it does in animals, water regulates the plant's temperature and transports nutrients throughout. Plants use their roots to take in water, and for photosynthesis, they require water to create sugar for food. Pressure from the process of osmosis, the movement of water from the outside to the inside of the plant cells, maintains the structure of the plant's cell walls. Plant cells have a large central vacuole in which they store water. Plants take in water through capillary action. Xylem vessels move the water from the roots to the rest of the plant. After reaching the leaves, the water escapes through small holes called stomata, which open to allow carbon dioxide to enter and oxygen to leave. This also helps the plant cool down. Similar to how people sweat, this process is called transpiration. Water is odorless, nearly colorless, and tasteless. It is in the food and beverages we ingest, and it makes up approximately 2/3 of our bodies, so it is no surprise that we cannot function without it. Water helps regulate our body temperature, brings nutrients to our cells, and flushes out waste. Our lungs are 90% water, our brains are 70%, and our blood more than 80%. Most people sweat out about 2 cups of water per day. During this process, we lose electrolytes, which are minerals like sodium and potassium that help regulate the body and need to be replaced. We can get about 20% of the water we require through food. Humans usually require about 8 cups or 2 liters of water per day through food or drink. Some foods like cucumber, celery, or watermelon are nearly 100% water. Currently, approximately 17% of the world's population, more than 1 billion people, do not have access to clean water. There are several organizations, including UNICEF and WaterAid, working to help disadvantaged communities in Asia and Africa obtain sustainable supplies of drinking water and sanitation facilities. Water shortages happen in the United States, too. Many states have programs to assist the disadvantaged with obtaining enough water and paying their water and sewer bills. Desalination is an important process that removes salt from water. Salt water can be bad to ingest because it results in dehydration. Scientists and engineers are hoping that new desalination technologies will help disadvantaged communities by giving them clean water options. Desalination processes force water under high pressure through a semi-permeable membrane. The membrane allows liquid to pass through, but not solids, such as salt. This method of desalination is referred to as reverse osmosis. Desalination only meets a very small percentage of our needs, but scientists are always trying for improvements in energy efficiency. Scientists are excited about the use of graphene in desalination. Graphene is hydrophobic and repels water. Scientists have tested narrow capillaries made from graphene, allowing for rapid permeation. Graphene capillaries that are 1 atom wide are now inexpensive and easy to produce. The process would work by stacking layers of graphene oxide, a derivative of graphene, on top of each other. The resulting multi-layer laminate stacks have a structure similar to nacre, mother of pearl, which makes them mechanically strong. Researchers have discovered that thin membranes made from such laminates were impermeable to all gases and vapors except for water. Even helium, the hardest gas to block off, cannot pass through the membranes, whereas water vapor went through with no resistance. It could be a monumental discovery in terms of desalination capabilities. Fresh water is important to economic development and the environment. Population growth and changes in climate have created an increasing demand for fresh water around the world. Desalination of ocean and brackish water is a possible solution to clean water shortages. Scientists at the Naval Research Laboratory are conducting research into using seawater as fuel. In the next 7 to 10 years, scientists claim that the military will be able to run jets, ships, and other vehicles on a fuel derived from seawater. The process is called a fixed-bed catalysis, where they are able to recover hydrogen and CO2 from seawater. However, it is currently highly energy intensive, requiring almost twice as much electricity to convert the water into fuel components. Catalysis is a process that combines chemicals, energy, and pressure to accelerate chemical reactions. Currently, the cost of the fuel is $3 to $7 per gallon, but those numbers should get better in the coming years. With a stable and clean electricity source, seawater-based fuel could reduce dependence on oil or other polluting fuel sources. There are many exciting and rewarding careers regarding science and water. For instance, the EPA, or Environmental Protection Agency, has the mission to protect human health and the environment. Therefore, it is their focus to promote excellent water quality while monitoring pollution and threats to our water supplies. Other exciting fields include water conservation, purification, and distribution and infrastructure. Corporations such as Veolia Water, Lockheed Martin, Atlantis Technologies, and Calgon Carbon offer careers that cover a wide variety of water-related issues. Water is essential to life and is one of the most important compounds on Earth. Every day, scientists strive to find ways to increase the size and quality of our water supplies. Through basic understandings of science, we've been able to acknowledge many of the mysteries of water, and in the future, there is plenty of room for scientists to improve the quality and availability of this precious resource.